Hi guys, this is Mr. Urrego. Welcome back to our series Beat the Test. It's a review for the geometry and of course exam. Okay, let's tackle problem number 21. First of all, let's read. So it says isosceles trapezoid PQRS is shown, okay, where PQ, alright, let's get a pen. So PQ is parallel. Those two lines mean parallel lines, okay? So where PQ is parallel to SR. PQ parallel to, so we put the information right away. We put one arrow, that means they're parallel. Select a statement of reason to each blank to complete a proof that shows the diagonals of PQ are, so we need to prove that SQ is congruent to QR. A couple things here. They told me already that the two lines are parallel. Second, they said this is an isosceles trapezoid. Guys, if this is an isosceles trapezoid, this side is equal to this side. PS is equal to QR. And the angles, base angles, are congruent. Same thing that happens when I have an isosceles triangle. These angles are congruent, these two sides are congruent. It's the same idea. Okay, so keep that in mind, the sides. All right, cool. Just all that information out of whatever they say. I haven't looked at this yet. So this is my proof. On the bottom, make your selections from the bank of statements. So they're giving me statements, so I don't have to guess what I'm putting here. Okay, start. Statement. Remember, statement, column, reason. Every single proof has two columns, statements and reasons. The first most likely statement is always given, okay, which is isosceles trapezoid PQRS. So they're saying this is an isosceles trapezoid. That's information that is given from the top. And also the two lines are parallel. That's given information. Next, PS congruent to QR. PS congruent to QR, you see? All right, cool. That's the definition of isosceles trapezoid. Excellent. 3, I have no idea. Then they say base angles of an isosceles trapezoid are congruent. Alright, so base angles, like I said, this is an isosceles trapezoid, therefore these base angles, by the way, the line SR and PQ, those two lines are called bases from the trapezoid. So angle S and angle R are base angles. Angle Q and angle P and angle Q are base angles. Base angles of a trapezoid are congruent. They can be talking about the bottom ones or the top ones. Let's see. Angles. Here we go. QPR. QPR is this little angle. It's not the whole thing. It is congruent to SRP. SRP is true, but no, no. I need the whole angle, so that doesn't work out. Okay. So that's not a reason right now. SPQ. So this didn't work out for me right now. SPQ, because there's no more angles. I'm looking for angles. This is the only two angles out there. SPQ. Oh, here we go. SPQ, the whole thing, is congruent to RPQ. RQP. Yes, those are base angles. They're angles from the top, but that's a base. So let me read that right here. So angle, so this will be statement 3. Someone labeled that S3. Someone labeled this S3. Okay, angle SPQ is congruent to angle RQP. SPQ, it fits right now, so that's what I'm doing it. It's congruent to angle RQP. Okay, I'm just going to use the letters, statements and whatever. Okay, S3. That's the main idea. Statement 3. Next. Reflexive property. Reflexive property. Okay, guys, reflexive property. We use reflexive property when we talk about one angle or one side. If I said angle A is congruent to angle A, then I use reflexive property. I'm talking about the same thing. So reflexive property. So we have that this angle is congruent to this angle, this side is congruent to this side. Okay. All right. So reflexive property. Let's look at the segments. SR is the bottom. is congruent to SR, but I cannot use the bottom right now. All right, I'm assuming that we're doing this right now. So let's talk about the plan. Our plan, I believe so. I believe our plan right now is to prove that two triangles are congruent. So I'm assuming that we're trying to prove these two triangles, triangle blue, and right now I have the angle P on the top and I have this side on the side. So, and I need to prove that, remember, the final answer is PRSQ. They want me to prove that SQ, this diagonal, is congruent to PR. To do that, I can prove two triangles, and let me get the other triangle, I guess, with green. Okay, to do that, I can use that triangle, and I can use the triangle on the right side. Okay, so I can use the triangle on the left, and I can use the triangle on the right. Right now, I have the sides are congruent, and I have that the angles are congruent. So if I can prove another side congruent, then that's it. My diagonals will be congruent by CPCTC. So I'm assuming the reflexive property is from this segment on the top, PQ. Here we go. PQ congruent to PQ. Because this is PQ. They share PQ. They share the same side. So both triangles share the same side. So PQ is congruent to PQ. Okay? And that's the reflexive property. And right now I have side, angle, side. Excellent. So they're sharing this on the top. They're sharing this on the top. Amazing. So let's go. Oh, now next one. This is it. So I just proved that those two triangles are congruent. So triangle, now we have two choices. All right. We got to label the triangle on the left, the blue one, and the triangle on the right. So this letter is S and this letter is R. So let's see, triangle, where is it? Triangle PSQ. PSQ. Then I have to start with Q. QRP, that's right. Triangle PSQ. Look at the order. PSQ. I go from my angle all the way to the bottom. Therefore, I got to go from my angle, Q, all the way to the bottom. Is congruent to triangle QRP. So this is my answer. PSQ, QRP. I followed the order. PSQ. Then in the other triangle, I got to start from my angle Q, go to the bottom, R, and end in P. Excellent. What's the reason? Side, angle, side. Side, angle, side. Do I have it on the bottom? Here we go. Side, angle, side. And we're done. After this, for the most part, guys, is the following. Now, because these two triangles are congruent, then I can say that the remaining side is also congruent. Okay? Because that's called, where's this? CPCTC. Corresponding parts of congruent triangles are congruent. This is my reason 6, and it's called CPCTC. Corresponding parts of congruent triangles are congruent. Very famous. And this CPCTC will be used for the most part our last reason. This is always used after we prove that the two triangles are congruent already. Okay? All right. Let's go to the next one. Yes, guys, let's keep this video by itself. This proof is amazing. So if we mix it with something else, it's going to be too long. So please, again, if you found this video helpful, please help us by liking the video and subscribing to the channel. It helps our channel grow and pushes our video up there so more people can see it, guys. Okay? Stay tuned. Thank you for watching.